Hello student, we are going to study about superposition of waves. In that chapter, we studied about what is meant by wave and which are the different types of waves. In 11th standard, we learn about waves and types of waves. What is meant by wave? Wave means oscillatory disturbance. In 5th chapter, we studied what is meant by oscillation. Oscillation means to and fro position and back and forth position from its mean propagation or mean position. If the particle vibrates from its mean position, therefore an oscillatory disturbance created by due to that medium that is known as wave. What is meant by wave? An oscillatory disturbance through a medium, it's called wave. If wave having two types, mechanical waves and electromagnetic waves. What is the difference between mechanical and electromagnetic waves? Mechanical waves can travel through any medium. Means medium is required to travel a wave from one particle to another particle. Therefore, that waves are known as mechanical waves. One point to another point, the wave will be travel. In that chapter, wave travel from one point to another point is known as the propagation of that wave, where the wave propagated through it in a medium that is known as mechanical waves and electromagnetic waves. Medium is not necessary for the propagation of light or propagation of the wave. That waves are known as electromagnetic waves. Mechanical waves, any material medium required or any medium is required for their propagation of that wave. Therefore, mechanical waves having two types. First one is the transverse wave and second one is longitudinal wave. What is meant by transverse wave? Transverse wave, in that wave, the wave propagate through medium. The medium is divided into alternate crest and trough. The medium is divided into alternate crest and trough. Medium is divided into alternate crest and trough. The vibration of that part of the particles are perpendicular to the direction of propagation. Particles are vibrate in a medium. Their vibrations are perpendicular to the direction of mean propagation. Therefore, that waves are known as transverse wave. The particles are vibrate perpendicular to the direction of propagation of the wave is known as transverse wave. And in longitudinal wave, particles are vibrate parallel to the direction of propagation. Compression and rarefaction. The medium divides into alternate compression and rarefaction. Medium divides into alternate compression and rarefaction. Therefore, that waves are known as longitudinal wave. Transverse wave, the medium divides into alternate crest and trough. And in longitudinal wave, the medium divides into compression and rarefaction. Therefore, the mechanical waves and electromagnetic waves, a wave which is continuously travel in a medium. A wave which is continuously travel means propagate. When a wave which is continuously traveling in a medium, that waves are known as progressive waves. That waves are known as progressive wave. Progressive wave, the characteristics of progressive wave or properties of progressive wave. Definition of progressive wave: a wave which is continuously travel in a medium. A wave which is continuously travel in a medium, and that medium is in the direction of propagation. Wave travels is in the direction of propagation of that wave. That waves are known as progressive wave. A wave which is continuously traveling in a medium in the direction of propagation, therefore that wave is known as progressive wave. Progressive wave, the characteristic or properties of progressive wave. Progressive wave. Each particle vibrate in a medium. Progressive wave means each and every particle vibrate in a medium. Second, each particle vibrate. Each particle vibrate or oscillate through medium. It performs SHM. SHM means simple harmonic motion. Each particle vibrate or oscillate through medium, it performs SHM. Second property of the progressive wave: each particle vibrate in a medium having same amplitude and same period and frequency. Amplitude is same, period is also same, and frequency is same. Each particle travel in a medium, therefore its amplitude, period and frequency is constant or same throughout that wave. Amplitude, period means time, and frequency is same. Third property: each particle vibrate in a medium, it possesses transfer of energy from one point to another point. Energy is transferred from one point to another point. Energy is transferred from one particle to another. Particle. Fourth property of progressive wave. First property: each particle vibrate or oscillate through medium, it performs SHM. Second one is amplitude, period, time, frequency is same. Third property: energy is transferred from one particle to another. Energy is transferred, energy or momentum. Each particle will move in a medium, therefore it having momentum, change in velocity. Therefore, energy and momentum is transferred from one particle to another particle. But no matter is transferred from one point to another point. No matter is transferred from one particle to another. Particle is not transferred. Energy is transferred from one point to another point. And fifth property: in a transverse wave, Progressive wave means mechanical waves. Mechanical waves means transverse or in longitudinal waveform. Therefore, in terms of progressive wave means mechanical wave, transverse as well as longitudinal wave can propagate through solid, liquid and gases. But only longitudinal wave can propagate through liquid. Only longitudinal wave can propagate through liquid. Therefore, transverse wave, longitudinal wave are propagate through medium, for any medium, solid, liquid or gases. Therefore, but for longitudinal wave, their propagation, liquid medium is necessary, or liquid medium, it travels in a liquid also. Transverse. Propagate through solid, but longitudinal wave propagate through solid liquids. Only longitudinal wave propagate through liquid. Properties of longitudinal wave. The transverse wave vibrate, the particles are vibrate perpendicular to the direction of propagation. That wave is known as transverse wave. Next characteristic. And for longitudinal wave, the particles are vibrate parallel to the direction of propagation. That wave is known as longitudinal wave. In a transverse and longitudinal, they having energies transferred from one point to another point, but matter is not transferred from one point to another point. Hence, these are the properties, six properties of that progressive waves. The characteristic of transverse and longitudinal, definition of transverse and longitudinal wave is the one characteristic. Therefore, six characteristic or the properties of progressive waves we can study. Therefore, now we study about what is an equation of wave. What is that? Equation can be written in the form of variable. The wave travel through along x-axis, along y-axis and along z-axis. Therefore, the wave propagate through a medium along x-axis. It gives a displacement. That axis is y-axis. Therefore, that displacement and the equation along x-axis and with respect to time, that equation of wave can be written y in terms of variable x and t. The wave equation can be written as y in terms of variable x and t. X is the displacement along x-axis and t is the time, is equal to A is the amplitude of that wave. A is the amplitude of that wave. A sine kx minus omega t. That equation given in your textbook, yxt is equal to A sine of kx minus omega t, where yxt is equal to A sine of kx minus omega t, minus sign here. Therefore, that wave travels along positive x-axis. Wave travels from along its positive x-axis. In that direction, x, y, z axis, 4 quadrants, positive x axis, negative x axis, positive y axis and negative y axis. Means the values are taken as above the x axis and below the x axis that values are negative, -1, -2, 1, 2, 3 at that type. Therefore, the wave equation is along positive x axis. Wave equation can be written as along positive x axis. Along positive x axis. Similarly, the wave equation can be written as along y-axis. The wave equation can be written as wave travel along positive y-axis. Therefore, yxt is equal to a sine, where the variable wave travel along positive y-axis. Positive y-axis. Therefore, a sine of ky minus omega t. Again, we can write the wave equation along negative x-axis. Negative x-axis means wave travel from negative x-axis. That type of. That equation can be written as wave equation along negative x-axis yxt is equal to yt along y-axis. Yxt is equal to a sine kx plus omega t. What is the difference in between that two equations? Wave equation along positive x-axis, wave equation along negative x-axis. Only the kx minus omega term t, kx minus omega t, and here kx plus omega t. Wave equation along negative x-axis, yxt is equal to a sine of kx plus omega t. Similarly, we can write the wave equation along negative y-axis. Therefore, yt along negative y-axis is equal to a sine of ky plus omega t. ज्यावेळी निगेटिव्ह ॲक्सिसची टर्म रिलेटेड असते त्यावेळी इथे ब्रॅकेटमध्ये प्लस साइन येतं आणि जेव्हा पॉझिटिव्ह एक्स ॲक्सिस और पॉझिटिव्ह वाय ॲक्सिस तर ब्रॅकेटमध्ये kx मायनस ओमेगा टी येतो. इथे ky मायनस ओमेगा टी. In that type, the wave equation can be written as yxt is equal to a sine of kx minus omega t. Where k is in oscillation chapter, k is taken as force constant. Therefore, k is equal to that constant is related with 2 pi upon lambda. That constant is taken as k is equal to 2 pi upon lambda. Lambda is wavelength. Lambda is called as wavelength. Wavelength means to complete one waveform, the distance traveled on axis, that is known as wavelength. The distance traveled along the one waveform, complete waveform, then that is known as wavelength. Therefore, lambda is the wavelength. Omega, angular frequency. Angular frequency. K is 2 pi upon lambda. Omega is equal to Angular frequency means 2 pi n. Omega is referred as 2 pi n. N is called a frequency and omega is called as angular frequency. Therefore, the wave equation can be written as when the wave travel along positive x-axis, y is equal to a sine of kx minus omega t. Wave travel along positive y-axis, y is equal to a sine of ky minus ओमेगा टी. अलॉंग पॉझिटिव्ह वाय ॲक्सिस एक्स ॲक्सिस असेल तर ब्रॅकेटमध्ये येतात मायनस साइन आणि वेव्ह इक्वेशन अलॉंग निगेटिव्ह एक्स ॲक्सिस असेल तर या ठिकाणी ब्रॅकेटमध्ये टर्म येते पॉझिटिव्ह मीन्स y इज इक्वल टू a साइन ऑफ kx प्लस ओमेगा टी. आणि इन टर्म्स ऑफ y ॲक्सिस therefore y is equal to a sine of ky plus omega t. Now we can study about superposition principle. Superposition principle. What is meant by superposition principle? Superposition principle. Superposition principle. When two or more waves when two or more waves passing through the common point, when two or more waves passing through a common point, then each wave produces its own displacement in the presence of another. Therefore, the resultant displacement is according to superposition principle, the resultant displacement of that wave. Then its resultant displacement is the vector sum of the distances or the amplitudes of that waves. Therefore, according to superposition principle, the vector sum of if two waves, they are superimposed to each other. Therefore, y1 plus y2. They coming from at the common point. Therefore, it is the vector sum of that two waves. Then the wave equation, the resultant wave of that two waves is equal to y is equal to y1 plus y2 is the vector addition of that two waves. Vector addition of that two waves. Y vector is equal to y1 plus y2 according to superposition principle. Therefore, by superposition principle, addition of that two waves we see in next lecture, superposition principle.